Yeah, let's take some questions. Question number one says an inductor of inductance 10 millihenry having negligible resistance is connected to a 1.5 times 10 raised to the power of 3 Hertz oscillator. The inductive reactance is, in order to approach this question, the first thing to do as a physics student is to write down the parameters given. So looking at the question, they said an inductor of inductance 10 millihenry. So inductance L is equal to 10 millihenry, which you convert to Henry, and that will be 10 times 10 raised to the power of minus 3 millihenry. That's one, the first parameter. Having negligible resistance is connected to a 1.5 times 10 raised to the power of 3 hertz. That's the frequency. 1.5 times 10 raised to the power of 3 hertz of frequency. Okay, then you have to get the inductive reactance, as simple as that. So the next thing you do is to choose your formula correctly. As you already know, inductive reactance is connoted by the symbol XL, which is equal to 2 pi FL. So from here, we can say 2 pi multiplied by the frequency, which is 1.5 times 10 raised to the power of 3 times L, of course, which is 10 times 10 raised to the power of minus 3 Henry. So if you punch your calculator correctly, you get 94.27 ohm, which can be approximated to 94.3 ohms. That's option B. Option B is correct here. For the second question, the diagram is illustrated above, and the question says the AC circuit illustrated in the diagram has a frequency of 100 over pi hertz. The effective reactance of the circuit is, as you can see, this is an LC circuit. So to solve the problem, solution, you have to take down the parameters provided. And from here, the frequency was given to be 100 over pi hertz. That's one. Then your inductance is 2.5 Henry, while your capacitance is 25 microfarad. When you convert this, it's going to be 25 times 10 raised to the power of minus 6 farad. Take note of that. Take note of that. All right. The first thing to do is to recall that the effective reactance of this LC circuit, which is impedance LC, ZLC, will be equal to, if you check the previous video I made, you realize that I gave you something like this, XL minus XC all square, such that the square will cancel the square root, and it then becomes XL minus XC. So we have to get these respective reactances separately. The XL, which is inductive reactance, and that can be calculated using formula 2 pi FL, which will give me 2 pi times 100 over pi times L, which is 2.5. This cancels this. That's 200 times 2.5. That should give me 500. 500 ohms. That's for the inductive reactance. Then we move to capacitive reactance, which is AC, which can be calculated using formula 1 all over 2 pi FC. And that will be 1 all over 2 pi. The F, of course, is 100 over pi times the C, which is 25 times 10 raised to the power of minus 6. So the pi will cancel pi, of course. Punch your calculator. So when you punch your calculator correctly, you're going to get 200 ohms. Now, the effective reactance, which is ZLC, will be XL minus XC, which is now 500 minus 200. And that's going to give us 300 ohms, which is option C. That shows option C is correct. Now let's see question number 3. From the diagram illustrated above, we said the question says the applied voltage V in the RLC circuit is, as you can see, this is resistor, inductor, capacitor, AC circuit. Everything represented in terms of voltage, voltage across resistor, voltage across capacitor, voltage across inductor. So in order for you to solve this question, the first thing to do is to recall that voltage in an RLC circuit will be equal to root of VR, that is voltage across resistor square, plus VL minus VC all squared. And this is just it. Now, you are given VR to be equal to 12 volts, VC to be equal to 13 volts, and VL to be equal to 18 volts. Now, what we do, we just substitute the values here. So your VRLC will simply be 12 squared plus 18 minus 13 all squared, which will be 12 squared, that's 144, plus 18 minus 13, that's 5. 5 squared will be 25. And this is going to give me root of 169. Of course, root of 169 is 13 volts. Final answer, that's option D. So you can see it's as easy as that. Let's move to question 4. So before we move, ensure you are subscribed to this channel. Then if you've gained anything from this video, try to hit the like button and don't forget to share, because you might have other folks that need this. Okay, yeah. Question 4, as you can see on the board, I want you guys to quickly work on this and drop your answer, the answer you get, on the comment section, and let's discuss. So that'll be the end of the topic, simple AC circuits. See you in our next class.